Hi everyone. Today we'll be resuming our Angular portfolio series where we were building an expense tracker, and we have used several features of Angular new version V21, where we have used signals, then we have used reactive forms, then we have used routing and the lazy loading, HTTP client, JSON server, then we have touched based on the effects. And today we are going to look at the HTTP interceptors. So without further ado, let's just move to the interceptors, HTTP interceptors. So first we will try to see why we need to use these HTTP interceptors and what's the problem we are facing right now, where these interceptors can play a better role. So in our last video, we have added like sort of a loading and error handling inside every component, where a spinner was getting shown when we are trying to load and a bit of error handling being done. But what actually happens, so if we just look across all our templates, so the same pattern have been repeated everywhere. So in every like dashboard or either expenses or the budget, this if statement for is loading or error have been used. So, and the service, like every HTTP call was manually setting is load and error. So that was more of a like fragile in a sense. And in case if we later add any HTTP call, so what is going to happen if we forget to add this boilerplate code again? So this would be more of a broken user experience. So this is something which we were like adding. So this dot is loading dot set to is being added, and within the HTTP call, what we are trying to do, we are trying to set this dot loading to set to false. And in case of a error, we are also doing the same. So what does an interceptor is and how it's effective in our case? So an interceptor is a middleware that sits between our code and HTTP request. So like you can think of it's something between the pipeline. So whenever our code is executing, so it intercepts it and performs certain actions, and then within like every HTTP request and response, it's being called. So every single HTTP call passes through it automatically. So we just write a code or logic once, and it's being applied everywhere on every call. So you can think of it like as a security checkpoint at an airport, where every passenger needs certain checks to be passed, irrespective of which destination he is going. So he need to like get his like documents being checked, security scanning is being done, stamping for exit is like a stamp is being done. So these are the things which have been performed for every passenger irrespective of his destination. So you can see like our code is there. The thing that which is going to run is the interceptor. It's run before any request which goes out, and then comes the HTTP request, and it goes to the server. A response came back, and again the interceptor is being run again, and then our main code is going to get run. So what we are going to build here in this video, we are going to add 3 interceptors, like each handling one cross-cutting concern. So one is going to be a loading interceptor, because what we are doing, like we are setting is loading to true and false in every component. So irrespective of doing it everywhere, so what we are going to do, we are going to set it using an interceptor, and then every component get the loading state for free. So there is no manual is loading set anywhere over there. The second thing is going to be an error interceptor. Let's say if there is an HTTP error response. So instead of handling it everywhere, what we are going to do, we are going to catch it within the interceptor, and we do not need to catch it in the individual service calls. And the third is the auth interceptor. It's going to add an authentication header to every outgoing service automatically. So at this point of time, we do not have a real backend server, and we do not have a proper like authentication mechanism. But once we have a real backend, so then we do require this type of authentication. So we are going to add an interceptor for auth interceptor as well. So with all these these being said, so there is already a way of using interceptor in the old Angular, but as we are working along like Angular v21, so moving forward, we will only be using those strategies which are more relevant to our new version. So previously, what actually happens, like a class-based interceptor was used. You can see over here the export class loading interceptor, which itself implements HTTP interceptor. And then there was the using this class, the interceptor was implemented. But you can see there is a new functional and clean way of doing this. We just use an export constant, and we are going to name our loading interceptor, and the type is which is going to be used is HTTP interceptor FN. FN you can call for functional. And let's just quickly discuss one by one. So HTTP interceptor FN is a type alias for a function that takes two arguments. So what does it take? One is the request, the outgoing request, the HTTP request object, which is outgoing. So it's being provided or it's been taken by this. And what does it contain? It contains the URL, body, header, and everything which is related to a request. And the second thing is next. This itself is a function that passes the request to the next interceptor. The reason is that interceptors are being used in the form of a chain. Let's say one interceptor, when it fulfills, then it's passed on to the next one, then it's passed on to the next other one. So this keeps on chaining. So this is the reason like we are using this next. So what does it do? It passes the request to the next interceptor in the chain or to the actual HTTP layer if this is the last interceptor. So we have to always call this next request. Otherwise our request is never goes out. So you can see, as I just mentioned, the interceptor chain. So what actually happens? They form in a chain, like first the loading interceptor is being called, then the auth interceptor has been called, and then error interceptor have been called. So this is once we are calling our request to be initiated from our client to the server. But when a response came from the server, these interceptors are executed in a reverse order. So what actually happened? The error interceptor is going to get called first, then authenticator acceptor, and then the loading interceptor is being called. So each interceptor decides whether to modify the request or not, or whether it's just like pass it without modifying it. So you can see the steps we are using in this video is we are going to create a loading interceptor, then error interceptor, then auth interceptor. And we are going to register all these within the app.config TS. And some necessary changes which you need to do to modify and clean the service and the templates. So this will help us. So one more an important concept that we need to look into or we need to remember is that HTTP request is immutable. So we can't modify that request directly. So what we need to do, we need to clone it and then modify the clone. So you can see on the top, we can't directly set the header on the request which is coming because it's immutable and we can't directly modify it. So what we need to do, we need to get a cloned request of that. And within that clone request, what we are setting the headers. And then with the next, we are passing this clone request to the next interceptor. So with this a chain, what does this do? Like this immutability itself is intentional. Why do it exist? Like it prevents the interceptor from accidentally affecting each other's copies of the request. So everyone have its own copy and it's being cloned and sent to the next chain. So let's just create the loading interceptor. So what's going to do what this interceptor is going to do? It's going to set the loading to true when an HTTP request goes out and false when the response arrives. So this way we do not have to set it manually on the template or somewhere else. So whichever, irrespective of which component is triggering it. So this is going to happen. So let's just create a folder. So let me open our application first. Okay, just to quickly show you this app. So we do have the expenses and the budget, and we can add a budget and also, add expense and budget limit can be modified from here as well. So with this being said, let's just move to the code itself. So within the app directory, we are going to call interceptors, and we need to call this the file name. We need to call this loading.interceptor.ts. So this is basically the interceptor which we are going to use. So let me quickly copy the code for this interceptor. So I have copied the code of the interceptor, and we'll be quickly looking at the each part of this interceptor. But you can see over here, we have used this export constant and a loading interceptor being created using a new interceptor function. So with this, we are using the latest feature of version 21 instead of the old one. So let's just quickly move to the reason what does this code do. So we have pasted this code in our application. So let's just quickly see HTTP interceptor function. So basically this is the type signature Angular expect for a functional interceptor. So what does it tell? It tells the type script that this function takes a request and then a next and returns an observable of HTTP events. So what does the Angular do? This uses this type to validate the interceptor at compile time. So what does it do? It's inject expense service inside an interceptor. Sorry. So functional interceptor run inside Angular's injection context. This is somewhat similar as a constructor or a effect. So inject work here exactly as it does in component and services. So what we are going to do, we are going to grab this service so we can update its local is loading signal. So, and one more thing, the next request, what does it do? As I've already discussed, this is going to pass the request to the next interceptor and the change. So we must always call the next and request. So without this, we are not going to, this request is never goes out and the observable never emits anything. Then comes the finalize function. This finalize is the RxJ operator that runs a callback when an observable is complete, whether it's successfully completed or error or any or was subscribed. So it is the observable equivalent of a finally block in a try catch finally. So you can see over here, without finalize, we would need to set is locally is loading to false in both the success path and the error path. So you can see over here, in the success path, we could have you set it as false, and in the observable equivalent, you can see in the finalize, we have set it to the false. And over here, without finalize, you can see it's being set here inside the tab. And again, in the catch error, it's being set to false as well. So finalize have collapsed both into one line. And one more thing that we need to look into, you might be thinking that why we haven't used the tab inside, because previously we have used tab. So why we set to true outside pipe and use finalize for false. So instead of using tab for row. So you can see this is something, a way of doing using the tab. The reason is that the next request itself written a cold observable. We will be discussing what cold observable is itself. So it doesn't start until something subscribed to it. By the time first tab runs, so Angular have already rendered one frame. So it seems like it's lagging behind because it's rendered one frame with is loading is still to false. But in an actual case, it should be true. So setting it before pipe ensures that it is true before the observable even starts. So no missed frame. So it doesn't give a feeler that something has been lag behind. So let's just discuss what a cold observable is. A cold observable is one that does nothing until someone subscribes to it. So you can think of it as a like movie on a Netflix. So it's residing on their server, but unless and until someone is watching that, so and someone doesn't press the play button, so it doesn't play on its own. So it's a cold observable. But what a hot observable is, if we are like watching a TV show which is being live broadcasted, or we are watching a match, so it's already happening. So either we watch it or not, it's occurring over there. So this is a hot observable. So why does like this next request when it returns like cold observable? So the HTTP request doesn't fire the moment you call, and it fires the moment like Angular subscribe to the written observable internally. So what actually happens? So imagine we try to use tab to set loading. Let's say we have used tab over here. So what is going to actually happen? Let's actually discuss the sequence. What is actually going to happen? So basically the loading interception function is going to run, and it's going to call the next request. It's called. So what does it do? It returns a cold observable. So nothing fires because this is a cold observable. And then we have a dot pipe tab. So what does it do? It wraps the operator with the observable with operator. So the wrapped operator is returned to Angular. The Angular is further passes further up the interceptor chain, and eventually Angular subscribe to the whole chain. So only now does tab subscribe fire is loading set to. The reason is this is the point at which the Angular have subscribed to it, and then only this is set to true is going to get called. So this means the problem occurs at like step 4 and 6. Angular does like work between receiving the observable and subscribing to it. During the gap, Angular may render a frame like that frame sees like is loading as false. So the spinner never appears, and a bit of a one frame late being displayed or with a flicker. So this is the reason we have used this instead of using the tab. So you can see it was we were like setting with pipe. So what we are doing it over here when we are using this interceptor, so we are setting the expense service dot is loading dot set to true synchronously, and it's prior to this returning the next using the pipe, and no tab is being used. So what actually happening over here? You can see, let's see these steps again. Loading interception, so loading interceptor function runs, and this have been like set to true, run immediately, and as it is synchronous, so it's going to run immediately, and the spinner is going to show up. And then the Angular signals marks the template as dirty right now. And what does the fourth step do? Next request is called, then it again returns a cold observable, then pipe wraps it, wrapped observable return to the Angular, and then Angular subscribe this HTTP request and fires. So response then arrives and the finalize runs, and is loading dot set to false is done over here. So again, you can see, so it's going to re-render the spin on the very next frame. So no gap, no flicker. And you can think of a like analogy to is like we are ordering a food in a restaurant. So the wrong approach would be like waiter like take our order, and then he walks to the kitchen. The kitchen starts cooking. So only now at this point of time, waiter flips the cooking sign. So it means like now they have started the cooking. So it seems like the customer are confused. Either they are like orders are getting cooked or not, or they are going to get served how soon. But the right approach is going to be there like this. When the waiter takes the order, what does it do? It flips the cooking sign. So it right away flips it like we have started cooking and the order is being placed. And the waiter then like walks to the kitchen starts cooking, and at that point of time, the like customer is from the very beginning knows that his order is started cooking. So, and why does it like matters? Like again in the tab approach, as we have already discussed, like the certain frames are going to get missed, and a possible flicker is going to happen. And this is not the case if we are going to set it immediately. And one more thing, like why finalize is fine for the false case. So we have tried setting it to like true. But then we have a false case as well, where once we receive the response, we need to set it to false. So if cold observable caused the problem, why is finalize acceptable for setting is loading to true? Because the direction is different. As I've already told you, that interceptor, when the request is being sent, they are called in order from top to down. But when the response is being received, they are called from bottom to up. So the direction is different. We want is loading to become false after the HTTP response arrives. So which is inherently async anyway. So there is no too late for the false case. So we are waiting for the response by definition and the finalized file at exactly the right moment. So when the observable complete or errors do come, so no frame gap is possible because we are already deep in async territory. And you can see over here, it's loading must be after response. So this is the case like for it is loading is equals to false. This is way perfect. Now comes to the actual part. So I'm hopeful that you are able to know what like hot interceptors are and what sorry, hot observable and cold observable are. So now comes the like we are going to create the error interceptor. So we have already created a loading interceptor. So this is going to be a error interceptor. So let's just create that code. And again, it's going to get created in the app, the interceptors folder within the app. So this is going to be the code. Let me just copy the code first. So I have copied the code over here. We will be discussing like the whole code in detail. So let's just move to our critical definition, and then we're looking into onto this code. So let's just quickly discuss each and everything. So HTTP response error. So what does it do? Like this is more of an Angular typed wrapper around HTTP response. So it like have several useful properties like error dot status, the message, the URL, the error, and the status text. And there is a like a special case when the status is like equals to 0 is a special case. It means the request never reached the server. So this could happen if the JSON server which we have created is not running, or the actual API server is not running. The user himself do not have an internet connection, or any cross origin request error block the request. So, and we already used cache in the service, but there is a here it is centralized. So every HTTP error from every service call through this interceptor automatically. And the callback received the HTTP error response and must return an observable. So we have two choices, like either we use this return an empty array, or we just throw back the error. So we will be opting for the second option, where we would set the error on the service for the UI, then rethrow. So the observable chain is still errors out. So what does it mean? This means the UI show the error message, and any subscribe that has an error handler still receives it, and the app doesn't silently absorb or swallow the error. So we might need to handle downstream, and we need to show it, or try to rather than absorbing it, we need to properly handle it. So again over here, this throw error creates an observable that immediately like errors. So what does the function syntax show? Like error is required in modern JS. So it wraps the error in a factory function to prevent it being eagerly evaluated. So how this change the service? With this interceptor in place, like we can remove all the manual cache errors called from the expenses service. So you can see previously the cache errors were there. So now with that, so we do not have to explicitly do that, and we just swallow for like optimistic updates. So the what actually is going to happen, the error message is set automatically by the interceptor before the error reaches the service. So service itself just need to decide whether to swallow or rethrow. One more point we need to like discuss, like service dot error dot set null. So we clear the previous error at the start of every new request. So what does it mean? Like if a user have triggered an action, so error from the previous action have been like disappeared, and a request goes out. So without this error, previous error failure would stay visible even after the subsequent successful request. So if you want error to disappear automatically after a few seconds, so we can add certain things, like we can add a set timeout. So with that, then it is going to get cleared after a few seconds. So we are setting it to 4 seconds. So it's good. It's more of a good UX approach. So let's just move to the third interceptor we are going to have. Before that, let's just quickly see the code for the existing authenticator. Let's just go to the code. So the error is interceptor, you can see as somewhere on a similar lines, HTTP interceptor function we have used. And what we tried to inject, the expense service. And what does it do? In case like clear any previous errors, it's going to set it over here. And then what we are trying to build a user-friendly message, like this message is being sent, and from where this error is coming, this error is HTTP error response, which is from the actual HTTP pipeline we are receiving it. So if it's like 0, it says it can't reach the server. If it's 400, so you means it's more of a client side error. For 401, it's an unauthorized. 403, so we do not have the permission. And if the resource is not being found, 404, and for 500, you know it's a server error. So once this being done, service error is being set, and then the throw error is being sent. So rethrow, so the observable chain is still errors out. So this is the way it works. So let's just quickly move to the next one. So over here in the create auth interceptor, what we are going to do, we are going to again create a auth interceptor within the interceptors folder. So this is going to be our third interceptor. This is the code. So let me just copy this. So I have created auth interceptor. And one more thing you might be looking at, there's an authentication service which we are going to create in a while. And this has been used over here. So we have injected the authentication service. So let me add this service as well. And this time we are going to add this service within the services folder, auth.service.ts. Let me copy the code. Okay, so you can see as I have added that auth service, so this error is gone. Again, here HTTP intersection function is being used, and we have injected the authentication service. And within that service, we have created a token. A token is being used. If no token exists, so what does it do? It passes the request through unchanged, because there might be a possibility not every request is going to be like authenticated. It might be a public call. And then what it does it do? It's just clones the request. You can see, as we already discussed, is clone the request, edit the header, and then going to return the clone request, the auth request to the next interceptor chain. And let's just quickly move forward. So what we have done, we have already created the authentication auth service as well. So this again, interceptor is using this service, and you can see, as we have already discussed, the request.clone is being used, which we have already discussed to set the headers. And one more thing which is being used is the bearer token. So this is more of a authentication token, which is being used in the most common pattern. So when we'll be creating our own authentication server, we'll be discussing this in more detail. But for the time being, you can think authentication bearer token is being used in this way within the header. So bearer is a literal listing. It tells the server that what kind of token follows. So the server reads this header, validates the token, and either allow or reject. So what we have used within our auth service is btoa. So this is more of a fake token creator. This is a browser built-in sort of library that base64 encodes a string. So we used to create a fake token that at least look like a real token. So in production, this is going to be a JWT token, so which we'll be discussing later in the upcoming videos. So this is going to get written by our authentication server. So what we have done, we have tried checking the token. So as I just mentioned that if in case of a public API call, so we do not need to check it. So we are just throwing this request to the next interceptor. So this way it's being done. And over here again, like with the local storage, what we are trying to get, we are trying to get the token from the local storage. If there is any token, so it's going to convert this value to Boolean. Double not is going to convert any value to Boolean. So with a null value, it's going to become false. And if there is a token, so it's going to become a true. So what does it do? If the user was logged in before refresh, they stay logged in. So again, a login simulation being used in the authentication service. So a login user being used if user is admin or the password is password. A fake token is being like created and this being set and logged in is set as true. So this is the way it's sort of a hard-coded logging for portfolio is being used over here. So let's just quickly see how these three interceptors are going to work. Whenever I'm trying to add an expense, what actually happens? The loading interceptor is going to get called, then the auth interceptor is going to get called, and the error interceptor is going to get called in the very last. Then the request goes to the HTTP layer, and the server send a response. Again, the HTTP based on the HTTP layer, it came back. Then on the reverse order, these error interceptor is going to get called first. The authenticator is going to get called next to that, and the loading interceptor is going to get called, and then the expense service itself that receive the response. So they have been like changed. Again, I already discussed like the way they are going to get called. So now it's the time to register all these within the app.config. So we already have app.config.ts file. So we need to change our code to match this. So let me quickly change the code to this. So I have updated the code and you can see like these with fetch and with interceptor have been added over here in the import. And let me just quickly see if this, okay. And all those interceptors have been imported as well. So with this being done, let's just quickly move forward. So what does it do? Like with interceptors, you might have seen that we have deliberately put the interceptor in a sequence. So I'll be quickly showcasing that to you. So in previous code, when we were like using class, so we have to explicitly mention the class. But over here, when we are using the functional one, so we are giving the loading interceptor first, then we are giving the auth interceptor, and then we have used the error interceptor. So it's more of a much in a clean and no tokens, no multi-true, no class interception is being needed over here. So what we need to do, we need to like clean up our expense service. So we are going to update our like add expense and update limit method because we were like explicitly trying to uh, change certain things over here. So let's just try updating that. So I have this updated expense service code over here, and there is no isLoading set to true over here. So with this being done, let's just move forward. And what we are going to do, we are going to remove this like from the constructor as well. So I've done it within the constructor as well. Let me quickly show that to you as well. So over here in the constructor, within these pipes, we were like setting those to true and false. So we have removed that as well. So with this being done, let's just move forward. And now we need to clean the templates. So let me just try using this in or updating this into the dashboard expense and budget templates. So let me just quickly copy these two in the like these templates. So I have updated all these templates. So we are going to use this like isLoading state. And there is also an error state, which we are going to auto dismiss after 4 seconds. So this is going to be set using the setTimeout. So let me just add that as well. So we are going to update our error interceptor and we need to update this like set timer for auto dismiss. So let me just add this. So you might see like over here within this interceptor, we have used a set timeout, and this is going to set a 4-second timer. And let me just remove this. I have added this code additionally. So let me just remove this. So this is the set timeout we have used. So let's just move forward. So what we are going to do, we are going to like test all these interceptors. So first we will try to run our application locally and see if it works or not. So let's just go to the VS Code. So seems like some error is showing up. So what is actually happening? Interceptor. So I was missing some like packets. So let's just try running it and see if it works or not. So let's just go to the browser. So you can see the loading is running as it can't reach the server. So you can see the error appears for a certain time and it goes out. So let me just try adding once again. This one is getting stored in our local storage. So this is the reason we are still able to see the expenses. But let me just try adding, and you can see it's loading, but as it's not going to reach the main server. And you can see this is going to get removed within like a few seconds. We can improvise that because it seems like a jerk in a sense. Instead of telling the user that it's going to like vanish within 4 seconds, it just abruptly goes. So we can improvise on that. But you can see at least you get a feeler how Interceptor can help us implement that. Okay, so with this being done, so you might get an idea how Interceptor works and what's the benefit of using interceptors. So I'm going to push the code on the main repo. So you can go to the code repository and pull the code. One thing which I'm currently not focusing very much in these video tutorials is the actual code itself. My focus is to discuss more of a concept because this code can be quickly generated using any AI tool. But the actual concept, like what the interceptor does, in which order they are going to get executed, and how they are going to improvise. So these are the things which you need to know. So you need to be well aware of these concepts. Using them or coding them is not a very big deal. You just have to ask any AI coder and it's going to code it for you. But you get to know like what does it do and how effectively we can use it. And when we are trying to implement it using the new version, so which one we need to use. So we need to use the right MCP servers for these Angular like versions. So it should effectively use these like HTTP interceptor function instead of the previous call based code. So I'm very hopeful that you are able to follow along with me. And if you like the video, feel free to like and subscribe. And if there is any missing piece or anything you want me to add and improvise, so feel free to leave a comment. So thanks for watching. Bye.